Alright, this is the third part of our review for the matter, molecules to atoms, physical science, unit 1 test. We're going to talk about the structure of the atom. Key ideas to remember here are the proton and the neutron are found inside the nucleus and have about the same amount of mass. The electron is found outside the nucleus and has a mass about 2,000 times smaller than the proton or the neutron. And the electron and proton have the same amount of charge, but they're opposite types, proton positive, electron negative. All right, let's go through a quick review. You guys have done this several times, so you should already know it. So let's start with number 1, the smallest subatomic particle, and it's located outside the nucleus. We're pointing to this little guy here. What is it? If you said electron, you were correct. A neutral particle, it has no charge. We find it right here in the center of the atom. What is this called? If you said neutron, you were correct. Let's look at our third one, a positively charged particle. Right here, these little red guys, we used pink in our in-school model. It doesn't matter, they won't print pink on the test. So positively charged particle right here in the center. If you said proton, you are correct. This is spelled wrong. Proton, P-R-O-T, proton, P-R-O-T-O-N, proton. Anyhow, number 4, the area where we have this probability to find these electrons, these whooshing areas where we're running around, it refers to this sort of circular thing, path that it takes, but remember we talked about these clouds. Orbit or orbitals, electron clouds, energy levels, any of those would be a good answer for these. Energy level, orbital, electron cloud, orbit, they are all the same thing as far as what we've been dealing with in our class. All right, number 5, this area right here where the bulk of the mass is for the atom, we find these protons and these neutrons in this area. What area is that called? Good, it's the nucleus. Good. Okay, so you need to be able to identify the parts either on a diagram like this or by description as we've had it. Any of these definitions should be able to, in any way, shape, or form, should be able to identify what these particles are. Areas, particles. All right, again, a real big key that comes up here is that the mass of the neutron and the proton are about the same. The bulk of the mass is in that center, and that the electrons are so much smaller. It takes so many more of these to equal 1 proton. That's what it's showing you here. We've said about 2,000. This shows you a little more precisely. 1,800 electrons piled up together will equal the mass of 1 proton. Bulk of the mass is found inside the nucleus. We can think of this idea that the protons and neutrons are so massive, bowling ball versus a penny. And we did this in class. I showed you some large marbles. I weighed the large marbles, and then I added in these little puff balls, and the little puff balls had no significant increase. They certainly had mass, but they didn't really change the mass of the atom altogether. The number of protons identifies a specific element. That's sort of the critical piece in here. And the number of neutrons identifies their isotope. So we were looking at mass numbers in order to differentiate one isotope from another. But we look at the protons, the atomic number, to determine one element from another. Okay, and here's a quick summary of our atom. Again, the number of protons tells us the specific type. This has 6 protons, so it's carbon. This particular one has a mass number of 12 protons and neutrons together. 6 and 6 is 12, so it has a mass number of 12. and that is the most common occurring form of this element. This most common occurring atom of this element is carbon-12. So this would be just a normal atom right off the periodic table, and there should be 6 electrons in that neutral atom, and you can see them here, 1, 2, 3, 4, 5, 6, so it's not charged. The charge of an electron and a proton are the same amount of charge, remember, measured in coulombs. Neutrons have no electrical charge. Neutron and proton have the same mass. So comparing charge, E and P, electrical, proton, PE, EP, however you want to do it. And NP when we're charging mass, neutrons and protons mass. And we talked about generally that the electrons, the number of electrons will help us determine how things, one element or one atom interacts with another. We'll come back to this. And the identity is determined by the number of protons. We'll come back to this stability of the nucleus much later in the semester. That we don't deal with this until about June. And we won't really get to the symbols too much until June either, but you've seen these in things that we've done. I just haven't really explained why. I've just used them. And then our locations, the protons and neutrons in the nucleus, and the electrons in the orbitals. Or again, energy levels, orbits, or electron clouds, all similar to our use. Okay?